away a satellite needs to be from the Earth for a geosynchronous orbit. For those of you that don't know, this is what GPS satellites use. The reason for this is they are actually traveling at the same speed as the Earth's rotation. So as the Earth is rotating, the satellite is rotating with it at the same speed, so it always looks like it's in the same spot.
Right. It's always falling at the same spot.
Exactly. So if we've got a so what we need to do here is we've got the velocity, right, is equal to
And you
square
said
root.
geosynchronous, right?
What?
You said geosynchronous orbit?
Yeah.
Okay.
So my square root needs to go over the whole thing there. Okay. So in order to do this, we got to look up a few different numbers. We need to look up
Gravitational constant, the mass of the Earth.
Do you want to look
And
those
then we
up?
can
And
change.
while you're looking those up, I'll rearrange this equation to solve for the radius, because that's what we're trying to figure out, right? So the question is, what radius from the Earth does a satellite need to be at
Okay.
to have same velocity as Earth?
6, 7, 4.
Isn't it like times 10 to the negative some giant
11.
Number? Yeah, 11.
Yeah.
So we've got velocity. We're going to go ahead and square both sides, so we get velocity squared is equal to gm1 over r. And then from there, I'm gonna do a little bit of math here. So we're gonna time both sides by r, and we get r v squared is equal to gm1. And then from there, we can divide both sides by v squared, and we get this as equal to r is equal to gm1 over v squared.
Okay, so we have m1 equals 5.9722 times 10 to the 24th. 5.9722 times 10 24, and that's in kilograms. Okay.
And then I'm looking up the rotation of the Earth right now.
Okay. Just how fast it.
Yeah, how fast it goes.
So are we solving for the radius then? Yeah.
Yes.
Yeah, we are. Okay. You just did some algebra and
Yep.
showed us. Cool.
You can double check it and make sure that it's right.
It looks beautiful, Kip.
Dude, I can't find it. I mean, I guess we could calculate it if we wanted to. Oh, here we go. So it rotates at 1 1,669.8, and that's kilometers per hour. So we got to do some quick math here. And
get
switch
it in
that.
meters per second.
All right, so this is going to be times 1,000 meters over 1 km, and then times 60 minutes over, or whoops, that's backwards. 1 hour over 60 minutes, and so we get,
there you go.
6.
Are we
9,
doing meters per second or meters per minute?
Meters per second. Okay, 8.
Okay, so then
0, 0. And then we got, you want to take it from here? Or then this is divided by 6. This is going to be divided by 3,600.
Yeah, there we go. So 166. Is that 1669800?
Yeah.
Divided by 3600.
See, this is why I like to just be a physicist, because we never actually have to use numbers, and we would have been done with this question a long time ago.
Okay, so that is approximately 463.8 meters per second.
Hold on, Jaden. We might be having a... Not sure what's happening here. Huh. Okay. Yeah, so we've got... Sorry, what was it? We've got some questions here from Kelsey.
463.8 meters per second.
463 meters per second. Okay. So let's keep moving on here. So we've got 463 meters per second. And so we've got this equation up here. So we just plug it in and we get 6.67. You gave me a lot of numbers there. Times 10 to the negative 11.
You don't know how accurate you want to be, you know?
The important thing is, are we at the same sig figs on all of our numbers, Jaden? Because it's not looking like that. Okay. 463. All right. So now we plug that into a calculator, and we get what?
One moment, I am typing it in. And then let me put some brackets, because parentheses are important. And that is...
See, I'm telling you, this is why I like just, doing physics without numbers, because we would have been done like 20 minutes ago. We could have moved on.
It is much easier, isn't it?
Much easier.
Okay, so let me just quickly verify. You forgot your squared on the 463.
Yes, I did. Thank you very much.
So let's just double check. Okay, our result is how many sig figs do you want?
Dude, I don't care. You choose.
1.84 times 10 to the 9th.
This is meters. So this is meters from the center of the Earth. I
Yeah.
don't know if we want to go and figure out from the Earth's surface. I think we're good enough. If you want
Yeah,
to figure
I think
out
so.
this question is solved, but if we wanted to figure this out from, all we'd have to do is subtract the radius of the Earth here, and that
The
would,
distance from the center to the
yeah,
surface.
exactly. Cool, dude. Anyway.